Hello, welcome to Precalculus. And by precalculus I mean me trying to figure out precalculus. I'm still getting my shit together a little bit. Trying to make this whole thing ergonomic. Sort of doesn't want to be. But it's gonna get in there, man. I'm gonna first start by like redoing 6.1 homework, because confused me a little bit. I've never seen that before. Oh, this is attendance. February 25th. Oh, I was late as fuck. Alright. That's what I'm looking for. Alright, homework section 6.1. Am I allowed to do this again? Oh, okay, there's a review and practice. So I'll just start on question 1. Okay. And then also I want to pull up the like course notes. It's like chapter 6 handout. Yeah. All right. It's feeling a little chaotic so far, but anyway. If you are here, thank you for joining. And you know, if you're watching this in the past and from the future, good luck, man. I hope this will make sense at some point. I mean, it's got to. Somebody figured it out, right? All right. Okay, this is in a separate tab. I want to like attach it back. The worst part about like streaming anything is just having 10 tabs open. Holy shit. I thought I already opened it. I can't tell you how difficult it is to like go through life and be this stupid. That's the wrong one. Holy shit, this thing is the worst. I was talking to some other math student the other day, and they were just talking about how horrible Pearson is, right? And it's just like, it's the standard, right? And so everybody kind of just accepts that this is the way it should be, right? But maybe I'm also just like, I don't know. Brain dead. Okay. Here we go. We're on it. Okay, this doesn't give review problems. That's whack. Alright, fuck it. I'm just gonna go to the next homework that I haven't done yet. Okay, what we're doing here, this is, what is this? This is like the inverse sine. That's simplifying it. Okay. I'm using identities, I guess, to like factor some stuff out. Alright, so it's like I think this part has something to do with like using the unit circle, finding what this is, and then plugging it back into the unit circle using the inverse cosine, which will give only one answer. Done this a few times, but like the last couple times I did it, I was a lot more like held together on the material, right? With this one, I'm just feeling more chaotic in general. Okay, so I guess the way to find this, right, is you need to figure out what this answer is, right? Like the sine of -5 pi over 3. I believe we can ignore the negative in this case because of the inverse function, or the inverse identity, right? Or the negative identities. I had that paper here. Here we go. All right. So yeah, even on identities, that's what I was trying to think of. And so now, because of sine, the negative just goes in front of it afterwards. So now it's just negative sine 5 pi over 3. So we find whatever that is and then just make it negative. I'm pretty sure. But we'll find out because we already know the answer. Alright, next we look at the unit circle and find 5 pi over 3, which is 300 degrees, which is the sine of that is negative the square root of 3 over 2. And then we need to find the inverse cosine of that. Which means putting in the value of square root of 3 over 2 okay, I see what's happening. So it's like a conversion, right? We have this angle is this value. What happened here is we got the answer, the negative square root of 3 over 2. Right, but the negative that we already have here, because we moved it in front, it's just canceling itself out, right? So now we have the square root of 3 over 2. And that goes in here. And then you just are like, okay, well, if what answer for cosine, what length of cosine gives us this? All right, and so we just find this on the unit circle because we want an exact answer. Red is like intimidating right now. I need something like a little chiller. Yeah, it's chill. Because we need an exact answer using pi, most likely. We can check the unit circle. For the x value, square root of 3 over 2, positive, is pi over 6. It can also be (11 pi over 6). But the inverse cosine function has a range. And it confused me for so long, like, why does this function need a range? If it's truly the inverse of what we had before, then shouldn't it have the same domain and range as the original function? If it's just inverted, right? Like, that would make sense to me, you know? But they decided, like, we're just gonna limit it so that, just to save y'all trouble. And it's an arbitrary limit, right? It doesn't really matter what the limit is. But everyone in math just collectively agreed, like, we're just gonna make this a limit so we don't have to specify it all the time. Because it's just gonna save paper in the long run. It's gonna save ink. You know what I mean? It's gonna save some brain power. So it's like one of those things where it's like, it rubs me the wrong way because it doesn't actually make sense. Even though, like, there's a logic behind it, but I haven't found, like, the fundamental truth of math that makes this important beyond convenience, right? But yeah, so I'm trying to find in the notes where it has the range, but it might just be missing. I need to reorganize these things. But we do have this, right? Where the range is 0 to pi. So we know it can't be down here for the answer of this. It's got to be in this part of the unit circle, right? So there we go. Pi over 6 is the answer. And that's what I have discovered. So I got that question right for that reason. That's fun. And, you know, I'm just reviewing this because, like I said, even though I was able to do some of these problems before, all of the ideas are like still pretty confusing to me. Just like from a logic standpoint, right? But the fun part about all this is it's like about to get way easier, like after this week, because the next parts are like sort of redoing what we did in chapter 5, but like as a triangle problem instead of a circle problem, which is, it's gonna be nice. It's gonna be nice. I feel like this is the past 2 weeks has been like all of the hard stuff that's like new concepts, and then next week is gonna be like how to reuse old concepts. I'm pretty sure, but I'm not gonna check. I'm not gonna check right now. Is this it? I think I've found it. Okay, so I'll pull this out. Because that's what we're dealing with today. Got that. Got the unit circle is important. That's not important. That's not important. That's not important. Formula sheet. Another unit circle. Another formula sheet. Here's some extra paper. This is the stuff from chapter 5. Yeah. Chilling. More paper. Okay. I should have done all that beforehand. I apologize. But like I just had to you know. You know. Okay, now that the shit's together, we can yeah, move on to the next thing, which is a relief, because that was getting a little, what's the word? Chaotic. We'll go with that. All right. So this is question 4, and I think because I picked the last one, it made like a confusing one where you have to, or like an intentionally misleading one to where you can get 2 answers if you're not paying attention to the range. But I imagine this one will be a little simpler. This is a sine of 11 pi over 6, and it's positive. So I think negative or positive is like changing the result of which hemisphere of the circle it's on, east or west, right? But I'm not totally sure. We'll find out. Okay, so sine 11 pi over 6, put in the inner circle. Looks like the value is negative 1/2. The inverse cosine of -1/2? What's that? So that means I have to find where -1/2 is an x between 0 and pi, and it looks like that's 2 pi over 3. And that's our answer. Hallelujah. Thank God. I actually know how to do this. This is great. Whew. Like, I feel like all last week I was just like spacing out the whole time, and like I was hearing things but like they didn't make sense. But it's looking like some of it was digested. And I'm sure it's a little maybe easier to like, in retrospect, having these problems solved, like be confident in this thing, but whatever. Alright, this one is COS -1 1/2. So this is the opposite of what we were doing, right? Because I'm getting the output first and then using that as an input. Maybe. I don't know if that even makes sense. I'm not even totally sure what outputs and inputs are. Right. Anyway. Okay, so I find where this okay, I see. In the ones where it's not inverse, it's giving radian answer. In the ones where it is inverse, maybe? Are these radians as well? No, these are actual lengths of whatever. Whatever 1 is on the unit circle. These are like, I guess those are lengths too. It's like this, right? It's like this. Sorry, I'm just gonna lead all of this. So it's, you got a circle. I'm gonna draw just a part of the circle, the part we're using right now. 1/2, the inverse cosine of 1/2 is giving us I'm sorry, it's not even on this side. It's on this side. Because it's positive, right? That answer is right here on the unit circle, right? And this is not like a very good looking circle, but okay. And it's the 60 degrees, right, is the answer. Or pi over 4, pi over 2, pi over 3, pi over 3. What is pi over 3? Is that 60 degrees? That's 60 degrees. Okay, so the regular is like asking for an angle. And that's what radians are. Radians are an angle. Okay. Are they? They are. They're an angle. And the inverse cosine, it wants a length. It wants you to put a length right here. Gotcha. Beautiful. And this length is, because it's the cosine, this length corresponds to, sorry, I'm gonna just show you and show myself so I can be absolutely sure that I'm right. This length, that's what the x is, and that's why cosine is x. It's this length. Sine is this length, right? But it'd be for 60 degrees, so it's like from here to here, you know. This length here is our cosine, so it's this portion of 1, right? That's it. That's all I wanted to say. What do I... So the answer is pi over 3. Now that we have an angle, we can find SEC pi over 3. The secant of pi over 3 is the inverse of cosine. Yeah, which is x over 1. Right? Jesus, no. I think it's r over x. Yeah, okay. R over x. Which x is now 0.5. R is 1. I think 1 divided by 0.5 equals 2. Let's just check it in the calculator. It equals 2. You gotta love that. We can check the inner circle. Alright. So, it worked out. Gave us our answer. Beautiful. It's fun going back over these problems and just trying to like conceptualize what they mean, right? Because it's just like, it's hard to remember like this. Like what, like it looks so dumb. It's just letter, number, comma, letter, period, minus, number, parentheses. It's just, I feel like I need visual elements to make it make sense. So I'm trying to do this one quicker so I don't waste all my time. Yeah, okay, we got plenty of time till midnight. Cosine. Okay, we're looking for the inverse. So now we're getting... No, we're still... That was the same as before. Getting a length. Because it's the cosine, it's the length of x. It's negative. And I'm pretty sure with this even-odd identity, the even-odd identity from the sheet that we learned, right? It's like cosine and secant. Thing negative just does not matter. We can just... Okay, I don't know about secant. I'm not going to talk about secant. Oh, I'm looking at the wrong one. even odd identities. Yeah, for cosine and secant, we just take the shit out. We take the negative out. Does not matter. And I'm sure that has something to do with range, but we can just ignore it. I think that's an important step here. So we have, and I don't know if that's always true. All right, that's just what I'm gonna try that and see if it works. All right, so don't take my word for it until it works. And then I'm gonna try and figure out why it works if it does. So we'll just ease into this thing, right? So it's not like a bunch of random nonsense that I think I know. All right. So cosine of the square root of 2 over 2. Inverse cosine. So when I take x and find an angle from it, I'm using this to convert a length into an angle. My angle should be 45 degrees or pi over 4. Cool. So now that we have the length pi over 4, we're going to put that into the tangent function. And that will give us our answer. So tangent is y over x, which in this case is square root of 2 over 2 divided by square root of 2 over 2, which gives us okay. So these even odd identities, I was yelling about them, but I believe they worked in this question because it was giving us the regular function first. It's not going to work in this because the even odd identities aren't the same for the inverse functions. We're going to go with that. All right, so I'm going to start over. Inverse cosine, negative 2 over 2. Even odd identities do not matter for this. We're just going to skip over the idea that I said that. All right, but now we know. It's like, it's not that simple. It's not the same. They look the same. They're not the same. They're different. They got different properties. Can't just come up in here and start putting your biases all over new functions all of a sudden. But it was fun trying to connect the pattern, and it gave us 1, but it didn't give us -1. So that's where the issue is, right? So anyway, because we know the range is 0 to pi, which is the north hemisphere of the unit circle, when negative square root of 2 over 2 is x, that gives us 3 pi over 4. Maybe that's what I'm not understanding about even odd identities, is that I think what it's saying is you can't just move it out and it's the same. That's it. It's like you don't actually get rid of it per se, right? You're not just making it visible. You're just unable to move it out. And the even odd identity, which is it's what it's trying to tell you is like you're going to get a positive answer from putting a negative length. Maybe. That's all speculation. We'll come back to that. And if you know what I'm missing here, please let me know. Anyway, 3 pi over 4 is what we get for our angle. But it's not degrees, it's just an angle. So our 3 pi over 4, we have to put it into tangent. Am I doing this right? Yeah, okay, so it gives us negative root 2 over 2 divided by 2. No, the other way around. But either way, it's looking at the same answer, which is 1. Here's a negative 1. Okay. Thank God I'm warming up by like going through this stuff, you know. Alright, and let's do question 1. So hopefully this will be easier. Alright, we got... I'm gonna use green this time, like this color. That's a nice color. Alright. So we got... inverse sine. Arc sine. Inverse arc sine. Dude, what? I want to see the inverse arc sine, bro. Just limit the range even further and turn it upside down again. Flip it over the X, Y, and Z axis. It's getting crazy out here, dude. Dude, this is why I could never be a teacher, man, because it's just like, I would be fucking around too much. It's just so hard. Alright. So, this length, it's a length. Inverse sine, we have a length. And the regular sine function, our input, which is an angle. Our output is a length. The inverse sine function. Our input is a length. Output is an angle. Beautiful. This is what I just learned just now, like 5 minutes ago. So, like repeating it over and over again to myself makes me happy. I feel very satisfied knowing this now. Good Lord, it's beautiful, isn't it? Okay. So. This means this should be y at whatever point on the unit circle we're trying to find, right? And what I have written down here, the range of the sine function, which I feel like is going to be important at some point. So I better figure out what it is. The inverse sine function. Why am I flipping so many pages? Jesus. Did I get lost somehow? Oh, I tore it out. Okay. Here it is. Negative pi over 2 to pi over 2. So, it's got to be on the eastern hemisphere. And same with tangent. This is sine and tangent. This one's cosine. Arc cosine. Inverse cosine. Alright. So now that we know that, it's gotta be in the quadrant 4. It can only be quadrant 4 and quadrant 1. So that gives us the angle 5 pi over 3. And we take that angle and we find cosine from this angle, which looks like it's a half. So there we go. We did it. Everything worked. 5 questions in, and I'm feeling confident all of a sudden. That's very satisfying. But I skipped over question 6, which seems like it's gonna be giving me some shit. So we'll see. We'll see what happens there. Let's send it and just see what happens. All right. Question number 6. I'm gonna go to the bathroom real quick. I'll come back. We'll send it. Okay, I returned. It's gonna be alright. Everything's fine. Okay. So, it's very tempting to just look at this and be like, oh, well, I have 3 tries. I'm just gonna hit B and see if that's the answer. Right? It's like so tempting to do that. Because, like, why would I work out all this bullshit if it's not even possible? You know? Why would you sell me falsehoods? I'm tilted. Okay. But we're just gonna, for the love of the game, we're just gonna get in there and see what happens. So, inverse sine, length. We'll just go ahead and check if it's in the range because that's gonna let us know if it's B. So this length, 7 out of 10. What? I feel like this should have a pi somewhere. 7/10. Oh, it's above 0. Less than 1. No, it shouldn't have pi. It's just a... Okay, our range for the inverse cosine is... The inverse sine, sorry, is negative pi over 2 to pi over 2. It looks like this is within the range. I think the difficult part about this problem is I am not sure where 7/10 is the unit circle. I think like that's the missing information, and I'm not sure how to find it really. But we're gonna try some shit out just to see what happens. Because this is... What is pi over 2? I'm gonna check with the calculator to make sure this is in the range. Because I tried to do it in my head. I'm not entirely sure. Okay. So. Pi over 2 is this number. 7/10 is this number. It's within the range. 7/10 is like... Is this an angle? This is an angle. This is an angle. 7/10 radians is the angle. So I have to convert this to degrees? Is that the key? It's so confusing because there's no pi, right? It's like... So pi over 2 is 100%, right? But it's not 1. It's just 100%. Does this mean this is like... No. It has nothing to do with pi. It's a crazy question, dude. Oh, find the exact value. It wants me to use the calculator. So that was a lot of yelling into the sky for nothing. But I enjoyed it. I had fun. So I would just put my length in here. Gives us, that's degrees. I'm just gonna get radians. So it gives us 0.777 blah 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 radians. And then we just put that into the tangent function. And that gives us a length back. And it's within the range. So let's just simplify your answer. Shit, it's gotta be a fraction. No. What am I missing here? Alright, I'm gonna look in the notes and see if this is 6.2, I believe. Yeah? 6.2, okay. Okay, I did all that, Equation involving treatment defining number of solutions. Infinite number of solutions or no solution. Solutions should be in radians unless otherwise stated. I'm trying to find the problem that looks like this problem. Solutions that lie within one cycle. Okay, I think that's going ahead. I think there's maybe another way to solve this besides the calculator. I'm not sure exactly how. So it's a length. If it's a length, then it's the y value. I think I can do this with a Pythagorean theorem. Pretty sure. Which would be 1 is r equals the square root of 7/10 plus y squared, x squared. And this is the answer. We're trying to get x. Or okay, so it's 1 squared equals plus x squared. Okay. So that would also be 1 minus (7/10) squared equals x. Is that right? Yeah, subtract that over here. Equals x squared. Okay. I don't know. I can't remember how to square a fraction, so I'm just gonna how to solve 7 squared 7 over 10 squared. Nope, that's close. Is it just 49 over 10? No, that can't be right. Yeah. I'll just do 7 over 10 times 7 over 10. Yeah, that's the answer. Okay. Which should be 49 over 100, right? Yeah, 49 over 100. Okay, so I have 49 over 100. 1 minus 49 over 100 equals 51 over 100. I need the square root of that, which is square root of 51 over 10, right? Is that right? I'll let my cat in. He's at the door screaming. Okay. Square root of 51 over 10. Which I believe was our answer before, right? Which, what are we looking for? I'm finding y, right? Okay, that's x. So we have... and then 7/10 equals y. So now what? Hold on, 1 second. So I kind of find an angle where this is true. No, this is an angle. Do I need to write this down? Say hello to my cat. There we go. There's the cat. That's the true star of the show. All right. Way better. Okay, but as soon as I set the camera up, he moves. Alright. Anyway, enough of that. Back to math. Chuck, I'm not gonna let you in if you're gonna cause chaos. Okay. All right, back to it. Okay. So, we have stuff. And for tangent, right? It's asking for an angle. For inverse, it's asking for length, I think. And the length it's asking for is this length. And it's going to give us an output. The output of this whole thing is going to be an angle. But how do I find that angle without using a calculator? Because it wants a fraction, right? Or does it? How do I find that angle in my head? How do you take an x and a y and find an angle? There was an equation for this. So, in this triangle that we're doing, here's the x, which is this is, buddy. This is y. So this is sine. This is cosine. This is this value. So we have our triangle here. Come on, bud. Sit down. He's a good cat. He's causing chaos, but he's a good cat. He just wants to be included, you know? That's it. So we're trying to find this angle. How does that happen? Wait. Did I do this right? What I've done is 1 minus yeah, because this is 1. This length is 1. Because it's the radius of the circle. This is the radius. Okay. But there's an equation for finding this angle here, but I don't know what it is. Is it just... I feel like there's a shortcut, but I forgot what it was. Is it sine? No. I'm just gonna Google it. I think for this, I'm not supposed to use radians. I'm just supposed to use degrees. I don't even know anymore, man. Sine. Inverse. I'm just gonna try it with degrees and see what we come up with. .42 degree 427. This is why Pearson pisses me off, because it's like I feel like they're just not telling me what I need to know here to solve this. I don't know, dude. Let's see. I'm just gonna do the help me solve this function and see what they think, right? Because obviously there's something I'm missing. Like, I don't know. I feel like I'm most of the way there, but it's starting to grind my gears a little bit. All right. Find the exact value of expression. Okay, so it's within the range. I know that part. Which quadrant? The quadrant 1, because it has a positive y. Okay. By definition, sine is opposite over hypotenuse. Okay. Okay. Alright. So the radius is 10. Okay, this is what I'm missing here. It's this identity of the function in itself is y over r. So it's saying your radius is 10. If you see it written as a fraction, it's like top part is your sine, bottom part is your what is that? That's your radius. 10 is r. Okay. So it's saying don't try and do this weird math based on the idea of 1. Just use 10 as your radius. That works for me. That's fine. It makes it a lot easier. Okay, so 51. I got that. Great. Alright, so I got the square root of 51 is the cosine. Great. So I made it like about that far. Okay. Tangent of angle is equal to opposite over adjacent. Okay, but are you allowed to do that? Are you allowed to just like throw them back in there and make an angle out of it? Because this is an angle, not length. What the hell? I feel like this doesn't seem right. I don't understand. I do understand now. What it's saying, right, is like What is it saying? Okay, tangent of this angle is opposite or adjacent. Okay. Okay. So because we know this length is 7, this length is 50 square root of, or, but shouldn't this be an inverse tangent as well? If we're trying to find, or are we just skipping over the angle part entirely? Is that what it's asking for? That's what it's asking for right here. So it'd be 7 times the square root of 51 over 51, right? Did I just not read the question right? Because I was trying to solve for the tangent of whatever in an exact number, which was throwing me off. But like this is a little more straightforward because it's not asking you for what this value is, right? It's asking you, well, we'll see. Yeah, okay, that's the end. It's asking for what length are you going to input into this. It's not asking for what the output is, which is a lot simpler because you could never find the exact answer of that in a fraction in your head. Or maybe you could. Maybe there's some equation for it. Who knows? Okay, so now we know how to do it, right? It's, we got a triangle. Drawn out a triangle. 5. Sine is 3. And we got x here. I'm pretty sure it's 4, but we're gonna just math it out. 5 squared minus 3 squared. 25 minus 9 equals 16. Equals x, which this is x, this is y. Square root of 16 is gonna be plus or minus 4. We know it's in quadrant 1 because we found out by looking at the notes earlier, but we're gonna go through it again, is the range of the inverse sine function, which is what we got here. It's gotta be between negative pi over 2 and pi over 2. See, now my cat wants out. It's like, wait, you closed the door? I want to be able to roam as I please. Anyway, it's not negative, even though the answer to this is plus minus, right? The negative, we know it's positive because this is positive. So the result is 4 over 5. No, it's just 4. Right? It's getting a little too brainy for me. So we know tangent is 4 over 3. I hate that they just put the equals there though, because in the find the answer, there was none of that. The answer is really tangent of an angle equals 4/5, right? We'll see. I don't know. This is blowing my mind a little bit. No, it's 3 over 4. 3 is y, 4 is x. Okay, it's just that simple. It's just that simple. But see, here's my issue with it, right? Let's say I don't think if I put this into a calculator, it's going to give me that answer. But we'll see. Maybe I'm wrong. Maybe I just do not understand this as well as I think that I do. Or I'm confusing myself. Okay. It's fucked. I gotta know why. Because that's the answer. I'm glad it didn't give me that one as the first question, right? Because I would have just done it in the calculator and be like, oh, I can write that as an exact number. It's easy. So this, what is this? That's a length of 3 in a triangle with a radius of 5. I guess the inverse sine, the ability of the inverse sine is to find this angle, but we don't even need to know this angle because we can just plug in the dimensions of the triangle because that's the output we're trying to get anyway, because we're trying to get the length. We're trying to take an angle and turn it into a length so that we can put that length. No, we're trying to take a length, find an angle. Dude, this is maddening. Yes, this will end up being, this equation here gives us an angle. We don't know what that angle is, but we don't have to know. Because why? Does 3 divided by 4 give us that angle? No. This is what it's giving us. We're skipping the angle somehow, and that's just by we're using this as a substitution for the angle. We're using the arc sine with a value to represent an angle. And that angle is .36 degrees-ish. It's like 36.869. Yeah, we'll just call it 36.9 degrees. So if we put 36.9 degrees into the tangent function, we shouldn't get something very far off from 4/5, and that's what we get. So all I have to say is this is basically virtually the same as any angle. Yeah, this is an angle. This is a length. The whole thing all together. Inverse sine functions are an angle. What you put in there is a length. The number next to it is a length. Length times t function no trigonometric function length inverse equals angle. Trigonometric function normal with an angle equals length. Okay, I understand now. You don't even need to do both, is what it's showing us here. It's, you just need to simplify this to give you the components of this, and it will give you this. There we go. They're not different. This value stays the same. Regardless of whether it's inverse or not. This whole idea here stays the same. Maybe. I'm gonna be honest. Okay, so is this any different from saying, like, you know that your sine is 3/5? What is the tangent? That's okay, that's basically what it's asking, right? But in like a really shortened form. And I don't know if that's correct, right? But I think we're gonna do more homework and find out. Let's run it. Let's go to the next one. This is killing my brain. Question 7. Let's try it. So we know that tangent inverse is y over x. So tangent inverse is, or shit, tangent inverse is y over x, which means y equals 3, x equals 8. What's the secant? Secant is equal to, that's the inverse of cosine, so that means we got x on the bottom, radius on top, but we don't know the radius. So we gotta find the radius by doing 3 squared plus 8 squared equals r squared. So 9 plus 64, that's 73. So radius is the square root of 73. Plus or minus. But from the range, we can probably find which quadrant we're in. But because it can only be in here, it has to be this. It has to be in this side because this goes beyond the range. So in this one, all are positive, right? The range being here to here. Negative here to positive here. Which is pi over 2, right? But we're just going to visualize for fun. Because tangent can also be positive here. Yeah, but like not here. This is excluding everything but this. Just to keep it simple, they decided, which is great. So we got for secant, it should be the square root of 73 divided by x, and it's positive. and x is 8. So it should give us the square root of 73 over 8. No shit, I got it. Let's fucking go, dude. That was satisfying. All right, I answered these correctly. This was solve the equation on interval 0 to 2 pi. So our equation is does this just automatically go in parentheses? I think that's the case. No, it would probably have them. I think the way he told us to do this, right, is you just subtract 7 from both sides, which gives us 4 sine equals -2. Why? Okay. Shit. I should have reviewed the first part because it's like I'm having trouble remembering how to do this. Okay, I'm just gonna look at the help me solve this, right? Jesus. Okay. Subtract 7 from both sides. Okay, I did that part right. Okay, because nothing is in parentheses, I can just do that, right? So -2 over 4 is just -1/2, and that's how we get our answers. Zero to 2 pi. It can be -1/2 is 11 pi over 6. 7 pi over 6. Okay, so I think I was just overthinking this. It starts to get weird when there's parentheses. So okay, that's fine. Move on. And that one's the same. It's just easy, like, just very fast arithmetic. -1 divided by 2. It's cosine equals -1/2. Right. All right. Which yeah gives us 2π/3 and 4π/3. Yeah. Or x is -1/2. Okay. Hopefully they get a little harder. Nope, this one's easy too. It's is it? Whoops. Spoke too soon. Let's see what we got here. Okay. Size. We'll lower that. Alright. So we got secant, angle, +1, 7. This is -1. This is divided by 3. So should be 6/3. Secant. Gotta do the inverse. So it's cosine of angle equals 1/2. Okay. Which is, I'm pretty sure, the same as the last one. Except for positive, right? So it'd be π/2 or π/3 and 5π/3, I think. Fantastic. We're on a roll now. Okay, so I think this is the one where it's like you find the answer and then you do whatever's inside to it. So sine -1 is it's gotta be 3π/2, right? It only gives one answer, correct? I think so. Within this interval? Yeah? Unless when we divide it by 3. I think that means it's 3 angle, so divided by 3. Divided by 3. Is that just 3π/6? Or 1π/2? And then I gotta add 2π. Let's see if it's or gotta add the range. Do I just add pi? See if it still works. I think it's pi over 2 and 3 pi over 2. Makes sense. Because there's like... Alright, I'm not going to start drawing now. Let's try this and see if it works, and then if not, we'll... Is there one in between these? We have 3 till revolutions. So it should only... I don't know, man. Okay, so sine. Oh god. So, one answer, pi over 2. Okay, the range for... Did I just add pi over 2 again? So maybe pi is an answer? Fuck. I guess that would make 2 pi an answer as well, right? I hate this. Is it just the one answer? The range is for... Okay, the range is... The range is 2 pi. Looking. 2 pi over 3. Maybe it's 2 pi. Dude. Okay. Period of the sine function is 2 pi. Great. Interval 0 to 2 pi, there's one angle where the sine function equals -1. What's that angle? Pi over 2. What? Oh, 3 pi over 2. It's all falling apart, man. All the solutions of sine pi. General formula is formed by setting the argument 3 pi or 3 theta equal to the angle found plus multiples of the period, namely 2 pi. I'm sorry, what? Let's write down what they're trying to say. Let's be clear. Alright, so they're telling me all the solutions may be given by the general formula. Which general formula? The general formula is formed by setting the argument 3 theta is equal to the angle found plus multiples of the period. The angle found is 3 pi over 2. Plus the period of 2 pi. However, is that the period? Is that the period of this equation, or is that just the period of the sine in general? Because the period of this function, I'm pretty sure, is 2 pi over theta, right? Omega. And I thought that this was omega. Is it just because it's not like sine 3x? Because just last week we were finding the period of a sine function, right? If you graph this sine function, is it going to look like that? Is that going to be the period? Is the period going to be 2 pi? I'm gonna look. I'm looking at the fucking graph. Does this, whenever you put theta in here, does that mean it's also inverse? There's gotta be a theta on here somewhere, right? How about R? What is R equals? What even is that? I don't know what I'm looking at. Well, this will be a great question tomorrow for the professor. Like, why does this not affect the period, right? That's what I want to know. And what is this an X? Or is that different than what we were just doing? Because sine. Whatever, at least we know how to solve it. It just feels ridiculous. Whatever. So we'll just do it their way. Wait, did I just skip the ending of this? Pi over 2 plus 2 pi k. Maybe that's it, is like after you find, that's when you add omega. Okay, I understand now. Because, okay, so he explained it this way in class and I didn't fully understand what he was saying. But this is what it is, right? I understand it now. Okay, so we got pi over 2, right? Plus 2 pi. Then you divide it by 3. Or maybe let's try it, shall we? I'm so confused. 3 pi over 2. This is 5 pi over 2 times 3. Is 15 pi over 2. This is ridiculous, dude. Okay. So that's pi over 6. 5 pi over 6. Nine pi over 6. Let's see if that's right. Please? All right, I get it now. I get it now. So what we're doing is just like we're finding the it's like we have pi over 2 plus the period overall, the period of sine. All of this over one bow. And we divide the period at the end because this answer would be outside of the range of this function. This interval, I don't understand it, but I know how to do it, so that's all that matters. I don't understand it. I just don't understand it. Whatever. I'm over it. So we're just gonna do the same thing again. Just don't question it. It doesn't have to make sense. You're just doing it in this order for this specific problem for some reason. I don't know why, but we're doing it that way. Okay. So that's 2 theta is equal to the inverse. Inverse sine of negative the square root of 3 over 2. Which is okay, so first we gotta do 4 pi over 3 plus 6 pi over 3 equals 10 pi over 3. We're gonna take this answer divided by 2. And we gotta take this answer divided by 2 and this answer divided by 2. And then we're doing 7 pi over 4 plus 8 pi over 4, which is 15 pi over 4 divided by 2. Okay, so it should give us shit. We'll write it down over here because I can't like. No, I'm gonna put it on the calculator. Okay. I don't want to waste paper. So our answers are, get the hell out of here. Are 4 pi over 6. Seven pi over 8. Ten pi 6. 13 pi 15 pi over 8. This can be reduced to pi over 3. Oh, it'd be so nice if I could just copy and paste this in here, right? Fuck. Alright, I'm just gonna type it out. No! Why? Oh, this one's not simplified. God damn it. All right, 2 hours in. 8 questions, 12 questions, not too bad. Fuck me. But still got 2 hours left before I have to turn it in. So, all right, from the top. I'm gonna feed these answers back into the calculator and see what I end up with. That will be fun. Sine of 2 times 4 pi over 3. And that gives us a positive answer. That's, well, first of all, is it the right answer? Just with the wrong... It is the right answer with the wrong symbol. Is this not possible because of the range? Range of... No, because the range of the sine function is... There's some answer that you can... Oh, it should be 4 pi over 6. Okay. Am I missing something? That one's not correct, somehow. Oh, 5 pi over 3. That's correct. 15 pi over 8. That's not correct. So I'm a little bit off on this one for some reason. I must have just done the math wrong. So, I'm not that far off. At least these two I know are correct. So, I found 4 pi over 3. Oh, should these be 7 pi over 6? 15 pi over 6? No. That's what I did wrong. Plus 2 pi is 6 pi over 3. So that would give us 11 pi over 3 divided by 2 gives us 11 pi over 6. I think I was just doing a little too much in my head, maybe. There we go. That's what happened. So I'm gonna change that to 11 pi over 6. And then the next one is just this 5 pi over 3 divided by 2. Which is 5 pi over 6. Let's try it. Yep. That should pretty well give us the fucking entire range, right? Of up until 2 pi. Okay, so I did it right. I just did the math wrong. Oh, I didn't change that one. Fuck me, dude. Well, at least got the right answer. I just didn't change this one. This is zooming ahead. Alright. There's only a few more questions, so it's gonna be alright. Not a big deal. Okay, this is the same thing-ish. So square root of 2 over 3, square root of 3 over 2 as the sign. It's giving us 2 pi over 3 times 1/2. That's giving us pi over 3 times 1/2. Right, correct. Okay, so should it be pi over 6? And 2 pi over 6. And then 2 pi over 3 plus 2 pi is 8 pi over 3. Right? Yeah. Which will give us 8 pi over 6. Which is really 3 pi over 2. And then pi over 3 plus 6 pi over 3, 7 pi over 3. 2, 7 pi over 6. Let's check them. Cool. Or that would be pi over 3. Cool. 3 pi over 2. Shit. I did that one wrong. 7 pi over 6. Okay, so how did I do this wrong? That was 2 pi, no, this is 2 pi over 3 plus 6 pi over 3, 8 pi over 3. Divided by 2. 8 pi. Wait. Yeah. 2 pi over 3 plus 6 pi over 3 is 8 pi over 3 times 2 is 8 pi over 6. Yeah? So I need 2 pi over 3. That's the output. Plus 2 pi, which is the same as 6 pi over 3. Which is going to give us 8 pi over 3. Which is times 1/2. Should be 8 pi over 6, right? What am I doing wrong here? Is this just not a... What? Oh, this is the same as 4 pi over 3. I cannot tell you how difficult it is to survive on this earth being this stupid. It's quite amazing that I've made it this far. Okay, so pi over 6, pi over 3, 4 pi over 3, and 7 pi over 6. I'm missing a few, I think. must be it. It's gotta be that. Yeah. I'm not even close to 2 pi yet. God damn it. Right, so let's keep writing them out, man. This is great. It's awesome. 2 pi over 3 plus 6 pi over 3. We'll do 12 pi over 3, which is now we're adding 4 pi just for fun, because you know we love math. It'd be fun if it was just not like doing it over and 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 over again. The same thing, the same way. Okay, but that's okay. But I gotta divide it by 2. 14 pi over 6, which is 7 pi over 3. Is that an answer? It's above 2 pi, isn't it? It is above. Oh. Okay. We're good. We're chilling. Let me do the other one though, just to make sure that there's not 5 answers. So pi over 3. I figured out what I did wrong. I gotta change that to 7 pi over 3, not 7 pi over 6. Yeah? Yeah. Okay. Divided by 2. Oh, okay. Plus 2 pi, which is, so that gives me 7 pi over 3 divided by 2 is 7 pi over 6. So that should be an answer, right? Is it an answer? I think there's one more on this string that I'm missing. It's just so annoying because it's just like so hard to keep it all together. Okay, I'm gonna try adding 7 pi over 3 and see if I got the right answer. I feel like there should always be an even number of answers, right? I'll be right back. I just one of those problems you gotta write down on paper and not like on a temporary whiteboard on your screen. That takes up most of the screen. I mean, essentially what we're doing here, right, is we're just making a new circle where 2 is the radius. Is that correct? Right? Am I wrong? Yeah? Does that have anything to do with anything? Or am I just making shit up? I don't know, man. No, that's not right. 'Cause that would give us like... Okay. That's more than 2 pi. Okay. 13 pi over 6. I have that one. 7 pi over 3. I have that one. 8. 7 pi over 3 is more than 2 pi, right? Did I just miss this because I didn't put a fucking comma in between these two? Dude, I hate Pearson so much, man. Is that a period? It's so small, man. Oh my god. I'm in pain. Okay, same question. Similar answers. Trying to get a half. Got 5 pi over 4. Oh, okay. I don't have to do any crazy shit. It's just 5 pi over 4 and 11 pi over 6. They gave me an easy one, so I didn't have to feel so stressed out. Woohoo! Oh my god. Okay. I guess gonna have to do it the fun way. So I got Oh. I just wrote the wrong. I just wrote the wrong answer. Alright. Oh, yeah, because this unit circle is giving me dyslexia. I just need to make my own unit circle. Plus 2k pi. Zero equals based on the smaller angle. Okay. Which is 7 pi over 6. And then this is the larger angle, 11 pi over 6 plus 2k pi. That's the first 6 solutions that are greater than or equal to 0. Fucker. Okay, 7 pi over 6. 11 pi over 6. And just keep adding 6 to the top number, right? No, you keep adding 12, so it's like 19 pi over 6. Uh, 23 pi over 6. Pi over 6. And 35 pi over 6. Please. Nice. Holy shit. We're within the touchdown. Solve the equation. Get the general formula for all the solutions. List 6 solutions. God damn it. Are there? Within this range? Okay, our base solutions are pi over 6 and write the general formula for all the solutions to sine 2 pi. Okay. This is just the same as the last problem. Oh, okay. Because it's got the different period. plus k pi. Okay, so pi over 3 plus, would that be? Okay, so I got pi over 3, 2 pi over 3, right? No, because that's not pi, that's a third of pi. 4 pi over 3. And then 7 pi over 3? Yeah. And then pi over 6. 7 pi over 6. And 13 pi over 6. That's gotta be it, right? Hell yeah. I don't even remember doing this. Okay, I'm just gonna do it from the beginning. I don't feel like it. Alright. Final solutions to... Ooh. Fuck. So it'd just be whatever times 2, right? That's it. That's the answer. That's fine. Or it's a half pi. Or a half times the angle. Right, that's what we got. So... it's like basically the same thing, just... times 2 instead of divided by 2. So our base set is shit. Yeah. Yeah. So these are not answers though. We gotta have 2 pi. Gotta multiply them by 2. This is 2 pi over 3 and 4 pi over 3. Plus 4k pi, right? So pi over 3 plus 4k pi. Right? So what I gotta do is, this is really what I'm looking at here. It's sine 1 over 2. Wait. Okay. Equals this. Find the period. What did the period second, right? After I found this, that's when I start adding the period. Then after adding the period. Which is 4 pi. Right, because it's 2 pi divided by w, or theta, which is, or omega, which is 0.5. So 2 divided by 0.5. I think that's 4, right? just gonna check. Clear, clear, clear. Okay. It's 4. Okay. So we should just be able to take this and add 4. K pi. But this only gives us 2 solutions still, right? That are within the range? Or no? No, because we're still dividing by 3 at the end. No, we're not. We're dividing by 3 before. Dude, this is brutal. Well, I'm gonna try that. Yeah. Okay, since it's bigger, there's probably less solutions. But there's still... That's a sweet riff. Alright. Alright, that'll work. Because the previous questions when I was answering this shit, it's like, oh, okay, well, we have 4 solutions here. And that's what had me worried. But that's because it was like this thing. It's multiplying instead of dividing. So because it's dividing, you have a bigger range for less amount of solutions. Sweet. Got it. A-okay. General formula for all the solutions. Okay, and that was what I was finding a second ago, which is all you have to do is take to find the formula, you use this part, which gives us 2 pi over 3 from the unit circle, right? Is sine. And for the rest of the formula, you do this thing here that we had before to find ranges, to find periods, because essentially you're just doing your base solution, which is these are base solutions, like the first 2 that you get, the first 2 angles. And then you just add blank k pi, and that's the period that goes before k, right? So I guess this is also part of the period, but k is the amount of rotations, right? The amount of periods. K is the amount of periods. Pi is pi. And so just like in it's disgusting looking. Just like in the other thing, it's in the chapter 5 where we did it's so hard to write with a mouse. I have this pen, but I just hate picking it up and putting it back down. W being the coefficient of x or theta, right? And then this being 2 pi, because it's the sine function. So it's 2 pi over 1/2, or 2 over 0.5 times pi, which is 4k pi. Write the general formula for all solutions based on the smaller angle. So since it's saying smaller angle, it wants us to use this one. Okay. And then we'll do the same thing on the next part of the question. We'll do the same thing for the bigger angle. And it's still the same period. So all you gotta do is just insert the bigger angle there. And I use these formulas to find the rest of it. So in this scenario, right, it's nice to note that the simpler way to add these, instead of just adding 4 pi to the front, is like 4 pi over 3 is just like 4 pi is the same as 12 pi over 3, because 12 divided by 3 is 4, right? So we're just taking these and adding 12 pi over 3 to each of them 3 times. So that's 2 pi over 3, comma, 14 pi over 3, comma, 26 pi over 3. And then for the bottom one, it's 4 pi over 3, 16 pi over 3, pi over 3. 28, does that simplify? 20 over 3? No. Alright. Hallelujah. The homework has been completed. Beautiful. How's everything? It feels good. So nice. Is that which home is that? The homework is due tonight. What's today? The 3rd? Yeah, okay. So I'm still a little bit behind. Ooh. This one's the next one. From the work on Thursday. Use the calculator, solve the equation on the interval. Easy. This is an inverse sign though, right? Yeah. So inverse sign of 1 point, round to 2 decimal places. So 1.08. Shit. Oh god. Okay. But there's two solutions, right? No. Yes. My question is, how do you find the other base solution, right? I guess if like it showed us how to do this too, but I just completely spaced it. I think maybe if we look at it in degrees, it'll. Okay, yeah. So it's like we got this thing. I think the logic is like we got this 60-degree angle here. We got the 60-degree angle here. Oh God. These both have the same sine values. Yeah? So let's say it's like the so okay, we got like total 90 here. I guess this has to be 61 degrees. This has to be 61. What was the answer? 0.64. So we need 100 degrees minus and 0 degrees plus. So I think the second answer is the same formula, just subtracted from pi. So I think the answers are these ones. And if I'm wrong, I'm just gonna do the help me solve this thing. Okay. Let's send it. Let's see what happens. So we got 1.07, which is 8 radians. Do I need to put pi there? I don't need to put pi there. And 2.07. And it just needs two answers, right? Because this is a positive solution. And once you get 2 pi, it starts going negative. Wow. I figured it out, dude. Let's go. I mean, pretty sure there's an... Oh, okay. Oh. Okay. I mean, this seems like it's going to be undefined, but I don't think it is. Inverse tan of 19. And then pi minus inverse tan of 19? Or... because pi is positive in... or tangent's positive in the third quadrant as well. So it would be like 3 pi over 2 minus... that. It seems logical to me, but I'm gonna draw it out. Just to double check my own logic, right? So, I need this. I wish it just defaulted to this smaller size pen. Okay. So it's a positive number, right? Or this is the length. Okay, yeah. The length has to be positive for tangent in quadrant 1 and quadrant 3. Yes. Yes. Perfect. So, whatever this angle is, which we can see what it is, my calculator, it's like 86.98 degrees. Yeah. So it should be like almost 90 degrees. Which the tangent of 90 degrees is undefined. tangent of 60 degrees is... I don't know, I'm not doing that right now. Fuck. The square root of 3 over 3, right? Yeah, the square root of 3 divided by 2, which is divided by 0.5, which is square root of 3 over 3. That looks like so yeah, more than that. More than that. And that's shit. That's a length as well, isn't it? I don't even know what that means. 19 what? It's just 19 over 19? No, it's 19 out of... X divided by Y equals 19. No, Y over X equals 19 is what we have here. Let me look at this. This is 19. But I don't know how that helps me. You know what I mean? This is the radius, which is not the same as this. Except for, of course, on 45 degrees. It's the same. But, like, down here, obviously the tangent is way smaller, right, than this length. So, if this is 19, this is something else. Anyway, I don't think that's going to help me here. It's just a proportion, I guess, at the end of the day, right? So, this also doesn't help because we don't know what the radius is. All we know is tangent 19 is what you put into your calculator, right? I'm just gonna put these answers in, dude. I'm just gonna put the answers in. The answers that I got on the calculator. Yeah. Wait, one more look at this. Okay. So it's not, it's like, I think the answers I have in the calculator are wrong because essentially what I have here in radians is a little bit less than pi, right? Is this also the angle I'm trying to find? It is, isn't it? Because he said, I remember him saying, oh my, dude, this is such a disgusting. I remember him saying that tangent is just a straight line across the x and y axis, right? So if this is our first answer here, then the second answer should be something like this. So maybe we're going for like, if we do pi plus this equation is going to give us the same thing. It's not. I think it's maybe this plus pi. If this is truly true. Well, that's what I did. That's what I did. So why is that not the case, right? Pi over 2 is 90 degrees. It's almost 90 degrees. Oh, pi minus. Nope. I think it's a pi plus, right? Because essentially I have 0 and I'm trying to get this length to here. And then I have pi and I'm trying to get this length to here. This length to here. Yeah, no, yeah, no. Okay, so I have a few possible answers here. And it's not this one. Wait, it could be this one. It could be this. I'm gonna try pi plus. That makes more sense in my brain. So let's see what happens. And then the other one being I'm looking for an answer that's less than pi over 2. No, it's less than 3 pi over 2. Which is what? What's this? I think this is the answer. I think I'm not doing this the proper way, but maybe I am. Who knows? Either way, we found the answer. Basically, what we did is found the inverse tangent, and then we just did pi plus the inverse tangent. And I think that's going to make sense because the period of the tangent function is pi. And what we're looking for here is maybe 2 period. We're looking for answers between 0 and 2 pi, which is 2 periods of the tangent function. So all we have to do is find our first answer, which is the only possible answer in the first period of pi, in the first period of tangent function, and then add pi to it to get the only possible answer in the second period of the tangent function. And I think that's right. Please. Yeah, dude. Logic, man. It works. Okay. They're throwing us a curveball here. They're giving us the negative 0.75. And I still have not come to the conclusion if this is like an even odd identity thing. I like this one because you could do it in your head. Maybe. but I'm not going to. And this is the same as just like this is the same as 3/4, right? Which means like if our triangle is this is 3 and this is 4. I might be overthinking this. However, thinking's the fun part. So I'm not trying to find this angle. Or yeah, basically I'm solving for this angle, right? Like what input gives you a 3? Yeah. Okay. So it's negative, right? So it's got to be quadrant 2 and 4. And we don't even know if it's negative, but quadrant 2 and 3. Like we think it's negative, but I don't know. I really don't know if it remains negative because of the even odd identities, right? Yeah, it does. If our triangle is -3, then that means it's going this way. So this is 4. This is -3. Cool. Uh-oh. I feel like one of the hardest parts of pre-calculus is so many specifics are left out, right? Because if this is true, and also this is true, and also this is true, right? So it's like, how do I know it's not just like +3 and -4, right? Which is in this quadrant, right? Because we know the cosine's negative? Well, what does that even tell us, right? How do we, like... Because that's never negative. That's just an angle. I guess in this case, this would be negative. And you're going backwards. Okay. Fine. You win calculus. Alright, so we got... I'm just gonna do it in the calculator. I'm like gonna confuse myself. So So it's giving us first solution is 138 degrees, which is like here ish. And that's 2.41 radians, which is less than pi. So now I need the second solution to be between 6.28 and what's this other one? And 4.71. No. Because x is negative. We're assuming. Yeah. Yeah. That's the easiest way to think about it. So we do like what, 3.14 minus 2.41? Or we just do pi minus the question, which is pi minus arc sine negative 0.75. So this value, we're going to take this value and we're going to add it to pi. Because it's 3 point. It should be about like a little bit over 225 degrees. Hopefully. But it's within the region we want, right? So I'm gonna try these answers out, these last two down here on the calculator, and see if that's getting us where we need to go. Essentially, it's 2.42 and 3.86, which are like so we have our solution that's between 0 and pi. I don't know, we can always just double check it, right? By like plugging this same thing back in to the cosine function. Okay, that gave us negative 0.75-ish. Like pretty close. Okay, so now that one's correct. Now I'm gonna try it with this one and see if it gives us a negative or positive value. Hopefully, it's giving us the one we want, right? It is! So, it should be that. Yeah. Cool. And like it sort of makes sense. And the reason it makes sense is because like, yeah, if you're in quadrant 1 and quadrant 2 and quadrant 3, you're going to the left with your x, you're going negative with your x, right? It's like okay, so it must be that in this situation, when your tangent is negative and your cosine is positive, when this is like the other thing, where it's like, oh, actually the tangent is the negative part, not the x, right? Then that just means you're using an overall negative. Like you're going backwards, clockwise. You're going clockwise, yeah. I'm just gonna tell that to myself for now, and we'll come back to it. Like I'll revisit that when my brain is a little bigger. Okay, secant. Secant feels like an orange to me. Yeah, okay. All right. Why can't we just have a calculator with secant on it, you know? Why do I have to type in this extra shit? Looks like there's no solution. That's what it's trying to tell me. So we'll try that. Fuck. I mean, buddy, it says it's undefined. I don't know what to tell you. We'll try it on the graphing calculator, see what it says. And then we'll have the fun opportunity of like discovering why it's not actually possible to do it on the calculator as it is. So it's what, inverse secant of negative 5.9. Okay, great. Now, how can I get that same value on a scientific calculator? So fucking silly, dude. Maybe it's this. Alright, so I guess you can just put the 1 over inside of the function as well. And hopefully that just works, because that's the way I just did it, and it worked, so there you go. Okay. Let's visualize secant. secant is the triangle made with the radius, the tangent, it's the third side of the equilateral triangle made with the tangent and the radius. Great. Is there only one value for secant then? Or like this is just getting way above my head now. I guess we're just gonna treat it the exact same way we did the cosine, because I don't know any other way at this point. Like the hardest part about pre-calculus is like these questions here, right? Where it's like there's like nothing to grasp onto mentally in this. It's literally just like, here are numbers. What do the numbers do? It's like I really can't wrap my brain. What? So this is an angle. Okay. Okay. An angle. We have a length. This is the length of the secant. Okay. Is this the angle? What? What's the angle? Is this angle still? It's still this angle. So like if secant's 2, then it's gonna be 45 degrees, right? Or any multiple 2? Or what? It always depends on it kind of depends on what the radius is, right? And does this formula just, is it every multiple of 1 that it works with? This doesn't have secant. Great. Secant 1/2. No, cosine 1/2. Oh my god. I'm not figuring this out right now. Okay, so we're just gonna do what? Pi plus this? No, first we gotta do pi minuses. Okay, this is 99 degrees, so it's 9 degrees away from power. Away from that. So we're just gonna pretend it's cosine, just to simplify things from my own mental health, right? Oh, this is line maker. That's pretty neat. Helps a lot. Cool. So our first angle we found is this, which means when the secant is this value, which is like this is the secant, then this is the angle we get. It's like this would be the tangent right here. So the tangent should be super fucking long. Okay. So what we got for this is in radians 1.74. I'm gonna do pi over 2 again because I need to memorize it. This is 1.57. And our second solution, because So once again, negative should be like here in this area. I'm thinking it's gonna be like this, right? No. I think it's... We're gonna try both and just see which one is correct, right? That's the best way. Because, like, theoretically, I have no idea. I have no idea. I need to start clearing some of the shit out. Oh no. Okay. Okay, this is where I started working on it. This one here. Okay. So I have this. I gotta do like pi minus this. That's giving this angle, or this distance, this angle. Yeah. So I'm thinking I just add that number to pi now. That's what I did in the last problem. That gives us 4.54, which is this. Maybe, because what's 3 pi over 2? Yeah, so it looks right. Let's enter them, see what happens. The only other thing I could think of is the answer is, but that wouldn't make any sense because it doesn't have like a associated x value, right? So like the secant length is going to change if it's this. Yeah, this will give the same secant length. Yeah, because they're both just trying to do this thing with a tangent. All right. So like, yeah, this is still cosine? No, it's not. In this graph here, we have, this is tangent. This is also tangent. This is sine. This is sine. This is, like, this is cosine. I don't fucking know, dude. I don't fucking know. We're almost there. I've almost wrapped my brain around it, but it's just like so distant. I'm gonna work for another 30 minutes, and then whatever I haven't finished in this, I'll just do it tomorrow. Because like I've already been at it 3.5 hours. It's just at a certain point your brain starts to melt, you know. And still gotta go learn shit tomorrow, right? But who knows? You know, maybe it'll start getting fun here in a second, and like let's just start spamming. You know, I mean, what's another whole hour, right? To get that off your chest. Fuck. Oh, okay. I put in just. I got too much stuff in my calculator right now. Yeah. Victory, dude. All right, we have basically tan equals -7/5. Use calculator. Don't mind if I do. So what we did tangent right was just pi plus whatever we get, right? Can this be a negative value? It can. It can. Nice. But it's not within the interval. So we have to do it plus pi and then plus pi again to get what we really want, right? Hopefully. All right, and so for the tangent function, it's going to be quadrant 1 and quadrant 3. And these look like they're within those quadrants, right? I want to plug them back in before we hit check answer. I'll do a little bit of work. I'm feeling lazy now, but I'll do a little bit. It should be close to 7/5, right? I think 7/5. Yeah, it's 1.4. Okay. And then our second answer was just pi plus. So we should be able to plug in this here. Yeah, it's basically also almost exactly the same. Okay, I just got to make sure that I did the rounding right. Whoa, what did I press? Oh god. Alright. 5.33. Yeah? Please? Nice. Holy shit. Alright. So just move the 5 over and then divide it by 8. So it'd be like cosine equals 5/8. That's going to be in quadrant 1 and quadrant 4. Because cosine's positive now. The other two questions we did, it was negative. Right, now we'll just take the calculator. Do the inverse cosine. Gives us I hate when it does this, because like if I round this up, does this go up? This goes up too, so now it's just 0.9. Was the answer 0.9 or is it 0.89? I guess 0.9 is closer, right? 0.90? I don't know, dude. I feel like if I just make it 0.9, then I'm leaving out a shit ton of information, right? Whatever. I didn't invent math. Okay, so the way we did last time was just, I don't know if it's gonna work this time because those were negative. But let's see, we did pi minus that. I'm gonna do the whole fucking drawing thing again. What's this in degrees? 51 degrees. So it's like a little less than 60, a little more than yeah, so that's 0.9 R. And it's we found that for this range. So yeah, I think what we need to find is this, right? Because that's in quadrant 4. So we have this angle, 51 degrees. So their answer is going to be 360 minus 51 degrees, right? So it's 2 pi minus. I mean, it's not the most elegant way, but it's still giving us the right answer. And I'm just saying that because we have this angle here. We're trying to find this angle here, right? Just so that we're still in 2 pi, right? This line is definitely here because it's the distance. The distance between... The distance is the same. I don't know. I'm gonna try it and see what happens. It doesn't seem like the proper way to do this, but like, it is a way to do it, right? I feel like there's one like fast rule that like I should learn to like actually answer these questions correctly. But we're gonna try this. See if we get what we need. 0.9 and 5.39. And we'll plug them back in just to see if we get close to 5/8. Yep. That one's definitely right. This is the one I'm not sure about. Not even close. Oh no, yeah, it's close. Yeah, that's right. Okay. 5.39. Yeah? Fantastic. It feels wrong. It feels like cheating. It feels dirty. But like, yeah, I mean, you know, what I was gonna do would draw it out, right? I'm sure it'd be easier if I knew more. Let's see how I want to see how they solve it. Oh, they're not gonna tell me. Whatever. Well, screw you guys then. I don't know who's shown here watching this, but I appreciate y'all. Yeah. If you have any questions, let me know. I feel like my way of like saying things can be dumb sometimes. I try and like overcorrect and like explain in like the most complete version of it, but I know that like my mind like skips over stuff, or it's like I think things but I don't say them out loud. So I'm trying to literally just say everything that I'm thinking as it comes into my brain. But I'm like a student just like y'all are, man. So, you know, I'm not the authority on this stuff. I'm really just trying to like figure it out now so that like I'm not lost in class, you know, because I feel like teachers, they'll like skip over stuff that's easy to them because they're like, I feel like every teacher does this. It's like, and everyone has a little different learning style, but they just like sort of like every teacher will just sort of like zoom through it, and it's like you sort of have to, because you can't really like set like a pace that works for everybody, right? It's like you're really just there to convey the information and get through all of it and make sure that everybody has access to the information, right? It's like our job to like take it home and study and find the way that works for us, right? And it's like, yeah, essentially that's the purpose of me being here, right? Is like I'm trying to present the information in a way where I also have no idea what the fuck any of this is. Hopefully it helps. Okay. Otherwise, anyway, it's also nice to just jam to some lo-fi too, you know? And that's the other reason I'm here. Just listen to some fucking lo-fi, dude. Alright, so solve the equation. Cosine, tangent. This looks like, so this is where we start using the identities, and I know for sure that like it's gonna become a much more frequently used item. And I just say that because like it seems like they've started to introduce more problems that are like blending the two of these, right? So it's like learning identities and memorizing them makes it so that you can look at a problem like this and it not be like, holy god damn it, what is this shit? So but this is not how to solve that, right? Now looking at it again, since zero's over here, right? It's like we set one of these to 0 and solve the other one, right? Which is one of the solutions is tangent equals 1 (-1), which I think is undefined, right? Because tangent's y over x. I don't know, dude. Let's see what the calculator says. It'll tell us if it's undefined. It's not. Hallelujah. It's, I guess 45 degrees. -45 degrees. So that would give us the answers of 3 pi over 4 and okay. First I going crazy with all that. I'll take a deep breath. Alright. We got -45 degrees, which is this angle, right? So it's 315 degrees, 7 pi over 4. Also, because the range of the tangent function is pi, we also have to do 180 minus 45, which is this one, right? Which is 3 pi over 4. So we have those. I'm gonna jot them down here on the calculator. Oh, the other one's 7 pi over 4. And then we solve for cosine equals -1 as well, right? Which is looks like it's pi. Pi and 2 pi. Must be it, right? I don't know if all these are okay, but they are possible solutions. So, yeah. I'm gonna type them in and see if that's the answer. I remember saying something like similar to this when we were in class the other day. It's like crazy to me how low my attention span can get, right? Like, I swear I was like locked in the whole time, the whole class. I was just like sitting there staring forward. I was taking notes, but like it was a week ago, and I like just don't remember. Please? Zero product property. Did I not? It's not 2 pi. 2 pi can't be in here. Because the range of the cosine function is 2 pi. Sine equals negative, or cosine equals 1 would give us 2 pi. So that can't be it. Nice. God, it feels good to be right. What can I say? Okay, there's 1, 2, 3, 4, 5, 6, 7 more questions. We're halfway done with this, man. I'm like, I want to be fucking done with this already, but like, I want to be done with this. I want to be done with it. But it's like, man, just 7 more questions and you can, and I'm all the way caught up to like where we are in class. It's like so tempting, dude. I'm gonna just try and burn through a few more and see if we can just knock the rest of this shit out, man, because yeah. Okay, this is the Pythagorean identity. Anytime you see just like squared, it's probably Pythagorean identity, right? That's just a good rule of thumb, especially for where we're at. I'm sure it gets more complex than that, but this is what we've been introduced to on our formula sheet, right? Is like, there is nowhere else that has been explained to us what to do with cosine squared yet, right? So we're just gonna have that sweet, beautiful assumption right now and not learn anything until it's taught to us, because that would be overwhelming if we knew all the possible things that we could do to solve this right now. So we got 1 minus what is that identity though? I gotta look. Okay, is this as simple as just taking the square root of both sides? Because I feel like it's not even the Pythagorean identity, because does it even matter? I don't know, but I'm gonna try that first. Just the square root of both sides, which is just cosine theta equals 1, right? Right? Because the square root of 2. Oh. Let's try some shit in the calculator, right? If I just do 2 sine squared 1/2 minus 2 cosine squared 1/2. That does not solve my problem. Ah, plus. Shouldn't that just equal 1, right? Okay. Well, I don't know. Let's try it the other way. Let's try it the cosine squared theta equals 1/2. Yeah? And find the square root of both sides. So we got the square root of 0.5. So inverse cosine should equal square root of 0.5. Okay. Looks like it's just 45 degrees, right? I'm sorry. Is the square root of 2 over 2 just the same thing as the square root of 1/2? Why? Dude, there's this guy, on Joe Rogan talking about how 1 times 1 equals 2, and just like losing his mind over it. I'm like having one of those moments right now. Like, why is the square root of 2 over 2 the same thing as the square root of 1/2? I don't know, but I'm not about to crash out over it. All that matters is we got the answer. And it's 45. And this, the cosine. So it's also 315. So it's pi over 4 and 7 pi over 4, right? Please? One time. Fuck. Okay, so let's try. Okay, 3 pi over 4 somehow works too. 5 pi over 4 works too. Because whenever it's squared, it can't be negative anymore. That's maybe why. I don't know for sure if that's why, but maybe that's why. Why not, right? Because square root is plus minus. There we go. Plus minus 0.5. There we go. I understand. Please? Well done. That's what it is. So, well, I mean, one of the answers. Okay. Move 2 over here. 2/4 is 1/2. So it's the same answers, right? Yeah, it's the same answers. It's just 45 degrees. I don't know if they did that on purpose, but this is another great reason I hate Pearson. We just need like teachers to unite and also hate Pearson. That's the key. If anything, the value of this YouTube stream can be like evidence that Pearson's ass. Although, look, at the end of the day, it's good practice, you know. I hate to be a whiner. Okay, we'll move this over here, and this is 1 now. I need to just use the pencil. All right. Divide both sides by 2. So I have sine squared minus sine theta is equal to 1/2. Okay, I think this is where I use the Pythagorean identity because sine squared can be replaced with 1. Wait. One minus cosine squared. One minus carbon dioxide squared. Minus sine theta equals 1/2. I don't know what to do now. Yeah, okay, that was pointless. I still don't know what to do. Let's try it again on this side with a different color so it doesn't start to look ridiculous. All right, this time I'm gonna try 2 sine squared equals sine Plus 1. Maybe. Nope. Okay. Maybe it's... Make this 0 and solve for this. Sine 0 equals 1. Let's put that as an answer. Okay. So... Oh. Yeah, okay, now we'll make this one 0. And it'll be 2 sine squared equals 1. Divided by 2 is 1/2. Square root of 1/2 is equal to sine. Okay, so I think it's just adding here the pi over 2. We'll try that. Pi over 2 plus all possible answers for plus minus 45, which are it seems fishy, I won't lie to you, but factoring. Okay. Many techniques we already know, such as factoring. Cool. I gotta put it in parentheses first, is what they're saying. I'm sorry. How's this? What? Oh. I'm looking at this problem the wrong way because I'm not looking at it as like a quadratic equation. It's like the b squared minus 4ac thing. Okay. Also, that plus or minus thing is a lot more satisfying for circles and angles. I mean, 1, right? Is it 1? Negative 1? No. Dude, I don't know. I gotta write it out. Okay, so it's what, x squared? 2x squared minus x minus 1. Is that x minus 1? So that'd be 2x squared. No, is it minus 2? Plus x plus negative x. No, that's not right. I need to take algebra again, dude. I like forgot all that shit. I did it a month. Okay, so that'll give me 2x squared. Okay, minus 1. Yeah? Does that be plus x minus 1 minus 2x? Okay. Figured it out. Oh yeah. I've been working on math for too long. 4 hours and 17 minutes. Apply the zero product property. Okay. I can do that. Is that not what I just did? Oh. I square rooted it. Is -1/2. So it's the solutions of shit. Okay, first I'll do sin equals 1, which is pi over 2. Oh yeah, I gotta add them. All. 7 pi over 6. Pi over 6. Please? Why not pi over 2? Oh, because you're making them separate. Okay, great. Okay, so now I'm gonna factor. Okay, so 2x squared minus 3x plus 1. Is this correct? So that gives me 2x squared 1 shit. Oh, I have the 2x here, so it's just x minus 1 both times, right? Yeah. So it's 2x times x is 2x squared. Negative 1 times x. Negative x. 2x times negative 1. Negative 2x. And then negative 1 times negative was plus 1. Okay, cool. Okay, so I gotta solve for x equals 1. And x equals 1/2. That's being sine. So that's pi over 2. Over 3. No. I should have just put y. I should just put y instead of x. Just put y. Don't confuse yourself, Zach. So it's pi over 6 because it's sine, not cosine. Pi over 6. It's 5 pi over 6. This has got to be the entire solution set, right? This one takes way longer than all the other homeworks, man. Or maybe I'm just like stupider this time. Alright. Ugh. Gross. So yeah, I'm gonna put Y this time. Because it's signed. So as not to confuse myself. So close to the end, man. We got Y squared minus 11Y plus 8. This looks like it's getting into the quadratic equation territory, but let's just see if we can factor it for fun. Let's two things to multiply to this that add to this, right? That doesn't look like a thing. I mean, the factors that are 4 and 2 only, right? So yeah, it's quadratic equation time. God damn it. How to do the quadratic equation. Negative b plus minus the square root of b squared minus 4ac. Okay. So negative 11 plus or minus square root of 11 squared minus 4 times A is 1, C is 8. And by that whole beautiful thing, by, what was it? 2A. Plus minus B, negative B plus minus the square root of B squared minus 4AC over 2A. Yeah, okay. All right, calculator. What you got for me? 11 squared minus 4, 1, 8 equals 89. Square root of 89 so we have 11 plus or minus square root of 89 over 2A. Okay, I'm not sure that helps. I don't know how that simplifies this. Did I do this wrong? Oh, isn't the score to 89 just 9 or something? Nope. Nope, that's 88. 81. They couldn't just make it like convenient, right? They had to make it some fucked up. Like, that's the exact answer you want, really? Disgusting. This is where I check out of math, dude. It's like, what kind of fucked up question is this? Let's see how they would do it. To make sure I'm doing it right. Can it be? Okay, hold on. That 3 sign was not there in the beginning. Oh my god. I'm so mad. Did I just miss it entirely? I have to look. Okay, it doesn't show on the screen. Whatever. Whatever. I'm just now realizing my homework's like over half the problem. Or my notes are over half the problem on this OBS. There we go. Okay. Maybe I should just double check the problem instead of having a fucking panic attack. Okay. I don't know how to factor anymore. So it's like 7x blank x blank. Something times something equals 9. Factors of 9 are 9. So I need something. It's getting depressing. I think my brain just might be a little too fried for this. I don't want to give up. Oh, it's different squares. 7x. No. Alright. I've hit the wall. So, yeah. There's only 4 more questions. I'll do them tomorrow. We're already ahead. I'm feeling good about it. The end. It was a nice try. I'm good. Thank you for listening and watching. And, yeah. Do it again soon. Goodbye.